Okay. Hi, Jeevan. Welcomes to YourPedia Snap channel. And you have a snap for structural engineering. And you have an interview in CPCB, right?
Yes, sir.
So, Jeevan, first of all, tell me about what are the indeterminate structures. We mostly construct indeterminate structure. So, what are the basic reason behind this? First of all, tell me the indeterminate structure, and then tell me why we are prefer this structure.
Yes, sir. Indeterminate structure can be defined as a uh, there are there
Make
are
yourself
requirement of
visible.
yes, sir.
Make yourself visible first. Yes. Now tell me.
Yes, sir. If equations of equilibrium is not sufficient to analyze the structure, then we call as a indeterminate structure, sir. Then we use normally this because it resists the maximum bending moment and less deflections. Sir, am
Okay,
I
if
audible?
yes, you're audible. If as you said that the equilibrium equations are not sufficient to analyze, so
Yes, sir.
how will we analyze such structure?
Some compatibility equations by cross-section properties in the structure, sir.
Can you tell me one or two compatible equation? What are those compatible equation?
Yes, sir. The strain energy in the structure will be minimum, sir. That is the principle of least momentum, princi- ch- the principle of total energy is minimum, sir. That equation.
No, I'm
And
asking cost. I'm asking the compatible equation.
yes, sir. In if take cantilever structure, then we at the cantilever at prop reaction, the deflection should be zero, sir. At fixed support, the deflection there is no rotation and deflection is zero. In if you take internal hinge, the moment is zero. That compatible equations.
I didn't get your answer. I'm not getting your answer properly. That how am I going to analyze the structure? Suppose that we have a proud cantilever beam and subjected to UDL over the whole span. And yes, you said that only equilibrium equations are not sufficient. So how I analyze the structure? Tell me some
Dep-
compatibility equation. How can I use this compatibility equation here?
yes, sir. Depending upon the structure. If for take an example of propped cantilever structure, sir.
Right.
Yes, is there one? It is a being a indeterminate one indeterminate structure. We need to one compatibility equation. By that one compatibility equation can be obtained that deflection at prop reaction is zero. By making that,
Okay.
we can analyze that structure, sir.
Okay. Is there any other compatibility equation also can we use? If I don't want to use this deflection at prop and is zero, can I use other
It's depend upon which configuration of structure, beam
same
or
structure?
structure.
Same structure. You have a probe cantilever beam subjected to UDL.
Yes, sir. Yes, sir.
Don't want to use the deflection at point B zero.
Yes, sir.
Can I solve in yes?
We can do, sir. If prop reaction will be fixed, first fix that prop reaction by moment distribution method, we can find that, sir.
Moment distribution method.
Yes, sir.
Mm,
Sorry, sir.
in the moment
Sorry, sir. This is
yes.
not on.
Okay.
No, sir. I didn't. I don't know other than this for this structure, sir.
Okay. As you said that the indeterminate structures carries the maximum bending moment. Determinate if we have a determinate structure, can't they carry the maximum bending moment?
Sir, indeterminate structure can have can carry, sir.
Indeterminate structures carries the maximum bending moment.
Yes, sir. Resisting capacity will be.
Resisting capacity will be, say resisting capacity depends on what parameter?
Depends upon cross section, sir.
So if you have a simply supported beam, L length hai, EI flexural rigidity of the given member, and the same span, but now the supports are fixed,
Yes, sir.
and the same loading is there. So the
Yes, sir.
on both the cases, cross section properties are same.
Yes, sir.
So how why you are saying that indeterminate structures catch the maximum bending moment? In what way? I'm not getting it.
If, yes, sir. If there is a simply supported beam and one is fixed beam, if you load the if we load the structures on structures, simply supported beam can carry less and give a deflection, maximum deflection. If same
Okay,
load on
suppose that
the
there's a point load. There's a point load at the center. What is the deflection in the simply supported beam?
there is a formula for the that deflection at maximum deflection, that is 5 by 384 and WL power
Point
4
load.
point load PL cube by 48, yes sir.
And if there's a fixed support, same point load at the center is acting,
Yes sir, that
what
is
will be
a
the
1 by
deflection?
4th, that is a 1 by
So
4th
deflect.
of.
Okay, deflection is getting reduced. What about the
Yes,
magnitude of bending moment?
bending moment also resisted by final end moment, sir. That is WL square by WL by 8. There is a WL by 8 on final end moments, and at mid supports for simply supported beam WL by 4. That will be neutralized by the WL by 8. That is final end moments, final
Yeah,
fixed end moments.
yeah. So that's why you can say that in that sense, this bending moment comes out to be lesser in magnitude due to the fixed support. You can say due to the more stiffness we are providing at the sports.
Yes, sir, yes.
ठीक है ना? So as you are providing the more stiffness at the sports by changing the sports condition, so in that
Yes,
case
sir.
the magnitude of bending might getting reduced.
Okay, sir.
ठीक है?
Yes, sir.
ठीक. And indeterminate structure, as I asked you, not don't say directly that we cannot analyze using equilibrium equations. In fact, पूरा बोलो इसको that such type of structure here we only equilibrium equations are not sufficient to analyze the structures. Along with equilibrium equations, we require some extra equations that can be compatibility equation, that can be strain energy, yeah, that can be energy equations. So
Okay,
along
sir.
with these equilibrium equations, we required compatibility equation or energy equation to analyze the structure, and such type of structures are the indeterminate structures.
Yes, sir.
And indeterminate structure we prefer in the construction work. Reason being that first of all, indeterminate structures having for the same loading for the same span, indeterminate structures carries the lesser magnitude of bending moment. So
Yes, sir.
lesser magnitude of bending moments. That's why lesser cross section properties will be required,
Yes, sir.
lesser cost will be required, so economical will be there. And in the same case, bending moment of the sports will increase.
Yes,
Bending moment
sir.
on the sport will increase comparatively compared to the determinate beam. So the cost of the construction of the joints, you can say cost of the construction of the sports, that comes out to be more, but the overall cost comes out to be less.
Yes, sir. Overall cost will
Okay.
be less.
Yeah.
Yes, sir. Thank you,
And
sir.
second reason is this: in the indeterminate structure, we observe the lesser deflection due to providing the more stiffness at the sports. So we are getting the lesser deflection in the members.
Okay, sir.
So for produce the same deflection, you can say you can apply the more load on the member.
Yes, sir.
Okay, so there's also one of the reason. And so these are the basically the reason. Okay, how will you analyze the data indeterminate structures? There are the two basically methods we have, huh? Force method
Yes,
and
sir.
displacement method. In what
Yes, sir.
situation we are using the force method or displacement method?
Yes, sir. Firstly, we find out the static indeterminacy and kinematic indeterminacy of a structure. Then we decide which method we go for. If static indeterminacy is less than the kinematic indeterminacy, we go for the force method. If vice versa, sir.
Okay. Why, if DSI is static indeterminacy less than the kinematic indeterminacy, you go for force method?
Yes, sir. If force method is assumed as a forces in structures are unknowns. That means uh, the some combat force being a forces are unknown. It be by these forces can be determined by compatibility equations. But how many compatibility equations are known by the static indeterminacy? So less compatibility equations in stat by knowing the less compatibility equations are required to solve, we go for the force methods. If kinematic indeterminacy is more, that means at joint displacements will be more.
Okay, so that means that you can say that so if DS static indeterminacy is less than the kinematic indeterminacy, we can say that the number of equations we required will be less. So
Yes,
lesser
yes,
calculation will be there. So lesser calculation will be there. So that's why we are preferring the force method. If static
yes,
indeterminacy comes out greater than the kinematic indeterminacy, then in that case I'll go with the displacement method.
yes.
As the decay is less than, so lesser number of calculations
Will be
we observe here. Okay.
displacement methods.
Yeah. What is the what is the kinematic indeterminacy? What is the significance of this kinematic indeterminacy? What this kinematic indeterminacy tells you?
Yes, sir. Being a indeterminate structure, uh, how the value of kinematic indeterminacy tells how many compatibility equations we make sure that for the structure to analyze completely.
Oh, and compatibility equations in what sense you are using in this case?
This is sense means there is a sigma fx is equal to 0 sigma. There is a three equilibrium equations, sir.
The sigma fx you use only when there's a forces are there. But you are
Yes,
using the displacement method. You are saying about the kinematic indeterminacy. In the kinematic indeterminacy, we have unknowns only theta and deflection.
sir.
Slope and
You are
deflections
asking
are
static
unknown.
indeterminacy, sir. You're asking asked static indeterminacy or
No,
kinematic?
I asked the significance of kinematic indeterminacy.
Sorry,
What
sir.
kinematic indeterminacy tells
Yes,
us.
sir. Yes, sir. I can say again.
Yes.
Yes, sir. Kinematic indeterminacy is total number of unrestrained joint displacements for any structure that we count on. We count on it. That is a kinematic indeterminacy. How many degrees of freedom? How many ways it can be displace? It is the this significance.
Mm, how many in how many ways it can deflect?
Displace. Yes, sir. Deflect.
Displaced. In how many ways it can displace?
Independent displacements
Can
in
you
a structure.
elaborate? Can you explain it? Can you brief it?
Yes, sir. If can I say with an example, sir?
Yeah.
Yes, sir. If for example, if take a fixed end supports, there is no way to displace in any sense that x direction or y direction or any rotating direction. If we can say if we can take hinge supports, uh, it can deflect only, it can displace only rotation sides. If any load applied on it, there is no possibility to displace x direction any y direction. If we take roller section, it can displace horizontal direction only and horizontal direction, and it can displace in rotation only, rotation, not displace in vertical direction. This significance known as uh, by knowing the kinematic indeterminacy.
Hmm. ठीक है. Let us suppose that you got kinematic indeterminacy of any structure equal to 2. What does it signify?
The structure will displace uh, structure displace two ways, any 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 two ways by applying loads that that would be restrained by that would be restrained by as any by means.
Structure will displace in two ways.
Yes, sir.
By applying the load.
Yes, sir.
Okay. So what is structural dynamics?
Structural dynamics. If sir, I didn't study dynamics part, but I can say any load that can repeatedly apply on any structure, that is a dynamic load of parts.
What is dynamic loading?
Which is not static, apply repeatedly after a periodic time.
Okay, उसको dynamic बोलेंगे. Are you sure? Like if there is
Sir?
an earthquake is there, let us assume.
Yes, sir.
So will it be dynamic or not?
Yes, sir. Dynamic.
So does earthquake comes repeatedly or periodically?
No, sir. But no, sir. I didn't study the dynamic part, sir.
Okay. Structural dynamic is the science, is the branch of science. Here we deals that whenever there is a dynamic load on the structure X, whenever there is a dynamic loading X on the structure, the changes in the structure, what type of changes in the structure that we study in the structural dynamic. That means the behavior of the structure under the dynamic loading, under the effect of the dynamic loading. So due to the dynamic loading, the effect of that dynamic load on the structure, we study that effect in the structural dynamics.
Yes,
Like
sir.
there is earthquake is there, like there is a blast is there.
Yes, sir.
Okay, that is a structural dynamics. Okay,
Okay,
what is
sir.
principle of virtual work done?
Yes, sir. In for a equilibrium structure, the total virtual force should be 0.
That is a virtual work done.
Yes, sir. Yes, that is the principle of virtual work done, sir. Virtual work done means total external forces and internal force. The work done by the external forces and internal forces should be equal to 0, sir. Sir, am I audible, sir?
Yeah, you are audible. Okay. Principle of virtual work done, ठीक है, as you say that. And the simply you can say like that also कि total external virtual work done is equals to internal virtual work done. ठीक है,
Yes,
that's
sir.
whatever you said that also correct. Okay, and can you tell me how we'll solve the indeterminate structure by consistent deformation method?
Consistent deformation method. Sir, I didn't study, but there is one redundant for. Sorry, sir, I didn't study, sir.
Okay, consistent deformation is a method is an example of what type of analysis approach? It a force method or displacement method?
Yes, sir, it is a force method, sir.
Okay. ठीक है. So जीवन, let me give you feedback.
Yes, sir.
ठीक है, तुम्हें पता, लेकिन तुम आधी चीजें पढ़ के नहीं आए हो. स्ट्रक्चरल डायनामिक्स तुम्हें पढ़ा नहीं है, कंसिस्टेंट डिफॉर्मेशन मेथड वगैरह ठीक है, वो चल जाएगा.
Yes,
लेकिन बाकी जो तुम आंसर दे रहे हो थोड़ा सा एक्सप्लेन करके दो तो दैट विल बी मोर बेटर.
yes, sir.
एक्सप्लेन करो चीजों को, एक्सप्लेन करके आंसर दो चीजों को, तो ज्यादा बेटर रहेगा. तुम एक ही लाइन
Yes,
में
sir.
वर्ड को खत्म कर दे रहे हो, ऐसा ना करो. अगर तुम्हारी
Okay,
कोई
sir.
स्टेटमेंट है जो तुम्हें पता है कि एक ही लाइन में खत्म हो जाएगी, जस्ट ट्राई टू गिव विद एन एग्जांपल, जस्ट ट्राई टू एक्सप्लेन इट विद एन एग्जांपल. अगर तुम्हारी
Yes, sir.
स्टेटमेंट 4-5 लाइन की है तो एक्सप्लेन स्टेटमेंट एग्जांपल देने की रिक्वायरमेंट नहीं होगी. बट अगर तुम्हें लग रहा है कि यहाँ पे एग्जांपल दे के ज्यादा अच्छे से समझाया जा सकता है, then give an
Yes, sir.
example along with that. But first ask,
Okay.
sir, can I take an example? Sir, can I solve? Can I tell you with an example? First, ask the interviewer. Okay.
Yes, sir.
ठीक है. So overall is correct. Overall is ठीक. Overall सही है तुम्हारा, लेकिन तुम्हें बस थोड़ा सा you need to go through your structural basic concepts first of all. Just
Yes, sir.
revise each and every concept clearly.
Yes. Yes,
बाकी
sir.
ठीक है, everything is okay. Anything you want to ask?
Mhm. Thing is, sir, I want to understand one doubt regarding the indeterminate, that is approximate methods of force, that is one force method and displacements method. Why we need different types of, that is moment distribution
method? We have slope reflection method, we have moment distribution method, we have a Carnage method. They are the different approach to analyze the structure.
Yes sir.
Like
Why
you invent one huh?
if if one moment distribution is enough?
More you want to ask?
Sir?
Anything more you want to ask?
No sir, there is no nothing.